Hello, this is Miss Moore, and today during chemistry we're going to discuss unit conversions again, but this time we're going to talk about something called the factor label method. Today's essential question: how is the factor label method used to convert between units? Today for the lecture you're going to need both a calculator and your unit conversion table. Okay, let's do this. Again, we'll start with a few terms. So we have something called a conversion factor, also known as an equality. And those are mathematical expressions that relate two different units that measure the same quantity. For example, if we were to measure the length of something, we could use a foot, we could use inches, and we could convert between the two using the equality or conversion factor, 1 foot equals 12 inches. So a conversion factor or equality allows you to convert measurements from one unit to another. A conversion factor or equality is a relationship between the units given, the known, and the units you are trying to find, the unknown. Okay, let's learn how to use conversion factors. So the steps for using conversion factors. The example we will use while learning this is how many centimeters are there in 56 inches. Okay, the first thing you should do when doing these kind of problems is to rewrite the problem as a math problem. So for step 1, we're going to write what we know, and we know we have 56 inches. And what are we trying to find out? In math, when you don't know something, your unknown is an x. So we're trying to find out what 56 inches is in centimeters. So there is what our math problem should look like. Okay, step 2, we're going to set up a grid and write the given or the known over 1. All right, so a grid, I call it a grid. Some people call it a T-chart. It doesn't really matter to me. I don't usually use the terminology T-chart because later in the year our grid doesn't look like a T-chart. All right, so we've written our grid, and now we need to take our known, which is 56 inches, and we're going to put that over 1. Okay, so far so good? Okay, on to step 3. Step 3 says determine which equality or conversion factor matches the units given in the problem. Use your unit conversion table. Okay, before we go on to step 3, let's talk about how to use your unit conversion table. So if you could get that handy. Today we're not using the metric conversion, we're using the bottom portion. I think it's the bottom 2/3, the unit conversion area. Okay, let's just talk really quickly about how to use this. So anything that's in the same row is equal to each other. So for example, it's true that 3 feet equal 1 yard. Okay, it's true statement. That's a good equality or conversion factor. It's also a true statement that 1 yard equals 36 inches. Okay. We could also say that 3 feet equals 36 inches. Those are all true statements. What I could not say, which would not be true, it's not true that 12 inches equals 3 feet. Untrue. Okay, they are not in the same line. All right? Okay, now let's see. Let's do step 3. Okay, so again, step 3 says we need to determine which equality or conversion factor matches the units given in the problem. That's the one we're going to use. So I wrote step 1, which is our math problem, down below. And we have the units inches and centimeters. So we're going to look through our unit conversion table. And I actually just put on the page the right one to look at, but you might have to search a little bit more. And I see 2 different equalities that have the units centimeters and inches. I have 1 centimeter equals 0.39370 inches, and 1 inch equals 2.54 centimeters. Now, the truth is, we could use either one and get the right answer. Okay, I'm going to pick the bottom one, just because. All right, so we're on to step 4, which is to put the conversion factor into the grid, setting it up so all units cancel out, and then solve. So let me jot down that conversion factor from step 3 that we picked. And we picked 1 inch equals 2.54 centimeters. All right, so what we need to do now is we need to take this number and unit and this number and unit, and it needs to go into these two places. And we pick which one should go where based on the ability to cross out the units. So if you remember, you can cross out top to bottom. So since we have inches in the top here, I'm going to put inches at the bottom. So I'm going to have 1 inch at the bottom and 2.54 centimeters on the top. Okay? Now the inches cross out and we're left with the unit centimeters, which is what we wanted. All right, so now the way to read this table is you multiply the things across the top. This is multiplication, and across the bottom, and then you divide. So we have, if you guys could put this in your calculator, 56 times 2.54. And I got 2.24 centimeters. And then if I multiply the bottom, 1 times 1 is 1. Okay, so we can kind of ignore the 1, which gives us an answer now of 142.24 centimeters. Okay, now we need to think about sig figs. Because the answer has a lot more significant figures than the numbers in our problem. Now this might be slightly confusing. Being that the 2.54 was not a measurement that you made, anything off the unit conversion table we will call a fixed number, which means you don't use it for figuring out sig figs, which means we're only going to use the 56. So the 56 has two significant figures, which is the 1 and the 4, which means we'll drop the 2 and everything beyond. And since the 2 is less than 5, it means we're just going to drop, right? So we have 1, 4. But we can't just leave it at 14 because that's not really even close to the number. What we need to do is turn that 2 into a 0 because 140 is close. It's a good placeholder for 142. So our final answer is 140 centimeters. Okay, let's try another practice problem together. So our example, how many liters are there in 4,598 pints? All right, so the first thing we do is rewrite this as a math problem. So our known is 4,598 pints, and we're trying to find out what that is in liters. Okay, step 2, write the grid and put our known in the grid. And again, we know 4,598 pints over 1. All right, now we need to find an equality that has pints and liters in it. So let's look back at the unit conversion table and see if we can find anything that has pints and liters in it. Okay, in the first row I see liters but no pints. In the second row I see pints and liters. Right here. Okay, so we need to put one of those, we need to put those two numbers in our conversion table, one on the top, one on the bottom. So, what do you think? Who should go on the bottom? And why do you think it should go on the bottom? I say 8 pints on the bottom because it can cross out with the pints on the top. So on the top goes 3.7854 liters. Okay, let me get rid of that stuff on the bottom so we have more room. Okay, so now remember what we're going to do is we're going to multiply across the top and multiply across the bottom. So if you guys could do that with me so we can see if we all agree on the answer. All right, now I got a number with a ton of digits. I got a 17405.2692. liters. I forgot to do something. We should see that the pints do cancel out. Over 1 times 8 is 8. Okay? So from there, we're going to divide. When you're dividing, something looks like a fraction, which number goes in the calculator first? The top one. So then I end up with 2,175.65865 liters. Okay, the last thing we need to do now is figure out the number of sig figs. So because these two numbers here came from the table, we're not going to count those into determining the number of sig figs. We're just going to use our original number, which has 4 sig figs, which means our answer needs to have 4 sig figs. So we look at this number here, the 6. The 6 is 5 or greater, which means we need to round up. So our final answer is 2,176 liters. It's now time to check your understanding. So I would like you to do each of these problems to the best of your ability and by yourself. So hit pause and do it when you think you're ready. Hit play, we'll go over it together. And if you could please, once again, do your answers in both standard and scientific notation. All right, number 1. First thing I'm going to do is rewrite this as a math problem. 2,598 pounds equals X grams. Then I am going to write my grid. And in the grid, I'm going to put my known, which is 2,598 pounds over 1. And now I need to find an equality. I found the equality on the conversion factor table. I found it in the mass section, and there are 2 that you can use. I ended up picking the one on the bottom, the top row. So 1,000 grams equals 2.2 pounds. Okay. Now these 2 numbers need to go into my conversion table, and I pick which one goes on the bottom by whatever's on the top for the given. So 2.2 pounds on the bottom. So the top is going to have 1,000 grams. Okay, to make sure I did this right, I'm going to double check. My units cross out. So now I'm going to multiply across the top and across the bottom. And that gives me a big old long number, 2,598,000 grams over 2.2. So now I'm going to divide. And I got 118,909.091 grams. All right, now we need to figure out a number of sig figs. Remember, the numbers from the unit conversion table don't count as for sig figs, so we're going to ignore both of those. We're just going to look at the numbers in our given, which was 4. So 1, 2, 3, 4. We're going to keep those 4. So we're going to drop from the 9 on, and because the 9 is 5 or bigger, we're going to end up with 1181. Okay, those 4. However, we need to add zeros for placeholders. So there's our final answer in standard notation. In scientific notation, we have to have 1.181 times 10 to the, how many times did we move the decimal to get it there? 10 to the 6th. And because the number in yellow is bigger than 1, it's a positive exponent. So that's our answer in scientific notation. Okay, before I move on to number 2, I wanted to point out a couple things. First of all, it's super, super, super important that you write your units. Okay, I wrote the units here and here and here and here. Make sure you write your units. It'll keep you from making a stupid mistake, like putting the wrong number in the wrong place. Also, make sure you double check that you wrote your units in the right place by crossing out units. It will make you, it takes an extra second to do that. However, you're likely to get the answer right. Okay? So now let's try number 2. Okay, step 1. Rewrite this as a math problem, which is 32 days equals X minutes. Okay, and then step 2, write a grid and put our known in the grid, which in this case is 32 days, over 1. Now I need to look at the unit conversion table, figure out which equality I'm going to use. Okay, and I picked to use 365 days equals 525600 minutes. Okay. Now these two numbers need to go into our grid, and I'm going to put 365 days at the bottom so that days crosses out with days. And the top is going to be 525600 minutes. And I'm now going to get rid of this stuff, get it out of my way. Alright, so I'm going to multiply across the top and across the bottom. And when I do that, I get a big old long number. You get 16819,200 minutes and 365. Okay, and from here I divide, and I got 46080 minutes. So now let's look at our sig figs. Again, these came right off the table. They may have already been rounded, so we're not going to count those. We're just going to look at our original answer, which was 32, 2 sig figs. So it's those two, which means I'm going to drop this stuff. And the 0 is less than 5, so we're just going to round down. So we end up with 46000 minutes. That is our answer in standard notation. Scientific notation, we need to have one number before the decimal, so we have 4.6, and we only need 2 sig figs, times 10 to the, how many times we move the decimal to get from 46,000 to 4.6? We had to move it 4 times. And 46,000 is a number bigger than 1, which means the exponent's positive. So in scientific notation, my answer is 4.6 times 10 to the 4th minutes. Number 3. Okay, let's write our math problem. I've got 184900 feet equals X miles. Step 2. I write the grid and put in my known, which is 184900 feet over 1. Okay. Next, I look for an equality that has both feet and miles in it, and I found 1 mile equals 5280 feet. Okay, when I put these two numbers in the grid, I'm going to put the 5280 feet on the bottom because I need the feet to cancel out. And 1 mile goes on the top. Get rid of this. All right, next I'm going to multiply across the top and across the bottom, so I end up with 184900 mile divided by 35280. Okay. When I divide, I get a number with lots of digits. 35.0189, 3939 mile. And now let's figure out our number of sig figs. Again, we don't worry about these guys. We just look at our original number, and it has 4 significant figures, which means we need 4 significant figures here. Which are those 4? We look at the 8, it's 5 or bigger, so we're going to round up. So our answer in standard notation is going to be 35.02 miles. When we change to scientific notation, we're going to have 3.502 times 10 to the, we move the decimal 1 time. 35.02 is a number bigger than 1, so it's a positive exponent. So I'm going to have 3.502 times 10 to the 1 miles. All right, there you go. That's it for today. Review and rewatch. Practice a few of these again. If you weren't able to get these right, try it again. See if you can get it after watching the explanation. Besides that, have a good one.